Today we shifted to the topic of applications of derivatives. See, application of derivative consisting of 5 small chapters. Okay. The first one, it comes to rate measure, right? Rate measure. The second one, tangent and normal. Okay. Tangent and normal. The third one here is errors and approximation. Okay. Errors and approximation. Okay. And the fourth one here is given by increasing and decreasing functions. Okay. Increasing and decreasing functions. Increasing and decreasing functions. And the finally it comes to maxima and minima. Okay. See, these are the 5 different chapters you are going to study. See here, totally this question carries a compulsory part D question for 5 marks, and the rest of the 4 chapters carries 5 marks. Okay. See, this is once again 2 plus 3 marks it is, right. So, this is a rate measure entire problem for one complete problem in part D, 5 mark. This next 4 chapters for 5 marks, this is 1 2 mark question, 1 3 mark question. So, now we start with the first one now today, that is what rate measure. See, what is this rate measure, which is an important one. See, in the examination point of view, this is a 5 mark question as I told already. See, now see what is the definition for this rate measure. See here if y is equal to f of x is a differentiable function. Okay. See, if it is a differentiable function, okay, then dy by dx, okay, dy by dx is called, okay, dy by dx is called rate of change, correct, rate of change of y with respect to x, rate of change of the variable y with respect to what, x. See, you have seen different cases it is now. Rate one variable changes with respect to another variable. Suppose you can take the circle. Okay. See, circle, what happens, the radius, if the radius is 1 centimeter, what happens, the area pi r square, that is pi. See, if the radius goes to 2 centimeter, r is equal to 2, area pi into 2 square, that is what, 4 pi. See, when the radius changes, with area also what, changes. That means area directly, that is rate of change of area, it is depending upon what, radius. Rate of change of area with respect to what, radius, that is be represented by dA by dr. And then you have seen the pressure, okay, and volume. Volume changes, pressure changes, correct, or pressure increases, what happens, similarly changes in the volume also. So, similarly we can write some of the things here now. See here, dA by dt means what, rate of change of area. Okay, what do you call this, rate of change of, okay, rate of change of area with respect to what, time. Okay. See, next to dc by dt, okay, what is this, once again we call rate of change of, rate of change of, C means circumference, right, circumference, right, with respect to time, rate of change of circumference with respect to time. Similarly, you have seen, I think you have studied in this one in the case of physics, if S is the displacement of a particle, rate of change of displacement. See, whenever we say that rate in the maximum time, the rate is measured, that means with respect to time only it is. See, suppose rate of change of displacement, if S is the displacement of the particle, ds by dt, rate of change of displacement with respect to what, time, correct, rate of change of displacement, okay, rate of change of displacement with respect to time, correct. rate of change of displacement with respect to time. I think you know that we called as what, you know, velocity. Similarly, rate of change of velocity with respect to time, dv by dt, rate of change of velocity it is, right? Rate of change of velocity with respect to time, what do you call that one, you know? Acceleration, right? Rate of change of velocity with respect to time, that is acceleration. Now, similarly, volume, correct? dv by dt, capital V is using rate of change of volume with respect to what, you know, time, that is called dv by dt. Similarly, the rate of change of one commodity with respect to the another commodity, that is dy by dt. See, I think in the previous classes of differentiation, you know, dy by dx means what, you know, differential coefficient of the function y with respect to the function x, differential coefficient of the function y with respect to x. Now, the another meaning for the derivative of the function, that is dy by dx, represents what, you know, rate of change of y with respect to x. I think this you have seen in the case of chemistry also. In your physical chemistry, I think you come across this situation, rate of a chemical reaction, at what rate the chemical reaction changes. So, that we represented by this dy by dx. So, now here we require some of the basic formulas, okay. Suppose if you consider a circle, okay, you know, area of the circle pi r square, circumference c is equal to 2 pi r, correct. Then if you come to square, I think you know the square is cube, okay. What is the volume of the cube? X cube, where x is what, you know, the length of the edge, okay. X is the length of the edge of the cube. Volume of the cube is equal to what, you know, x cube. Then what is the surface area of the cube? Okay, what is the surface area of the cube? Surface area S is equal to 6x square. Once again, x represents the length or the length of the edge. Edge means side. Okay. Then what we require, the next concept here is a sphere. What is the volume of the sphere? Okay, volume of the sphere. Volume of the sphere is equal to V is equal to 4 by 3 pi r cube. Volume of the sphere is 4 by 3 pi r cube. The next one, surface area of the sphere. Okay, surface area is equal to 4 pi r square. Okay, surface area of the cube is given by 4 pi r square, surface area of the cube. So, the next one here is given by the fourth one. It come across, I think, cone, right? What is the definition? This one, volume of the cone. I think you have seen this one now. Volume of the cone is given by 1 by 3. Okay, volume of the cone is equal to, right? V is equal to 1 by 3 pi r square h. Some of the very frequently used formulas in this chapter. Okay, so now we shifted to the problems on this, right? Find the rate of change of area of the circle with respect to radius. Find the rate of change of area of the circle with respect to the radius in 3 different cases, when the radius is 5 centimeter, 3 centimeter and 4 centimeter. See, the solution here is, okay, see now, we know that area of the circle is given by formula. Which formula it is? Pi r square. See, here we want the rate of change of circle with respect to what? Radius. So, that means we are differentiating this with respect to what? R, I think. So, that is dA by dr is equal to pi constant, right? R square differentiation to r. So, now in different case you see, when r is equal to 5 centimeter, what is dA divided by dr? Pi into 2 into 5, how much it goes to? 10 pi. So, it is area, you know, therefore, it is square centimeter. The second case, okay, what is the second case now? When r is equal to pi into, that is when r is equal to 3 centimeter. When r is equal to 3 centimeter, once again dA by dr is equal to pi into 2 into 3, how much it is? 6 pi square centimeter, right? I think the third one you can answer yourself. When r is equal to 4, what happens? It is pi into 2 into 4, it is 8 pi square, because area, you know, we are keeping this unit, that is in terms of square units it is. Okay. So, this is, see here one thing the observer here you can observe is, we are usually we are calculating the rate with respect to time. Okay. But here the thing is, he says in the problem, rate of change of area you have to calculate with respect to what? Radius, that is dA divided by dr, it is area, rate of change of area with respect to radius. So, now this is a 5-mark question in the examination. The volume of the cube is increasing at the rate of 9 cubic centimeter per second. How fast the surface area increases when the length of the edge is 10 centimeter. Okay. See, initially you can write, let, okay, V be the volume, right, V be the volume, S be the surface area, right, V be the volume, S be the surface area, and X be the length of the edge. Okay. X be the length of the edge, right. So, now what are the given data? The volume of the cube is increasing, rate of change of volume dV by dt, how much? 9 cubic centimeter cc per second, 9 cubic centimeter per second. How fast the surface area increases? Rate of change of surface area, that is ds by dt is the question mark. Okay. When the length of the edge is, that is when x is equal to, how much he says now? 10 centimeters, right. So, now volume is given. What is the volume of the cube? So, we know that volume of the cube is equal to, V is equal to, can I write x cube, length into breadth into thickness. Okay. Now, here you differentiate this with, okay, with respect to what, you know, time t. So, if we differentiate with respect to t, dV by dt, correct, x cube, I think in differentiation you know this, x cube we are differentiate, see if you differentiate with respect to x you are getting 3x square, but here you are differentiating with respect to what? T, therefore, it is 3x square into dx by dt, but here it is given 9, okay, dV by dt, 3 into, when x is given 10 into what, you know, dx divided by dt, thereby I think 3 1s are 3 3s are, see you may get dx by dt here, that is equal to 3 by 10, I think in terms of centimeters it is, okay, centimeter per second, dx divided by dt. So, now the next thing here is we want surface area. Once again, what is the surface area formula? S is equal to what? 6x square. So, ds divided by, once again you differentiate this with respect to time t. What happens? It is ds divided by dt, 6 into 2x into dx divided by dt. Okay. But you know, 6 into 2 into x is given, right, when x is 10, okay, and into dx by dt. What is dx by dt? Already you have determined this, that is 3 divided by 10. Okay. So, how much it is now? So, that goes to yes, it is 6 2s are 12, 12 into 3, how much it is, you see now? So, 36, 3 into, sorry, this is 10 square, I think, 100, yeah, here also 100, 110, 10 cancels here. So, how much it is, you see, 6 2s are 12, 36 divided by 10, that is finally equal to 3.6 centimeter square per second. So, the surface area ds divided by dt changes to 3.6 centimeter square per second. Very important question, examination 5-mark question, remember now. Once again I will go through. The volume of the cube is given, V be the volume, S be the surface area, X be the length of the edge. So, volume of the cube is increasing at the rate of 9 cubic centimeter per second. So, dV by dt is given 9 cc per second. What he is asking, how fast the surface area increases, he is asking ds divided by dt, when the length of the edge is given, the length of the edge side it is, that is 10 centimeter. We are using the formula V is equal to x cube, we are differentiating with respect to the time t, dv by dt 3x square into dx by dt, dv by dt is given 9, 3 into x square 10 square into dx by dt, 3 3's are cancel. So, dx by dt 3 by 10 square means 100, right. So, it is dx by dt is what? 3 by 100 centimeter per second. Once you know this, next we go with the surface area, S is equal to 6x square. Now, differentiate with respect to x, ds by dt, 6 into 2x into dx by dt, 2 into x is 10, substituting we are getting the final answer 3.6 square centimeter per second. Okay. So, in the similar way, see the third problem is similar to the second one, solve yourself. The volume of the cube is increasing at the rate of 8 centimeter cube per second. What is the data? dV by dt, right. The next is how fast surface area, that is ds by dt is asking when the length of an edge, that is when x is equal to 12 centimeter. It is similar to the previous one, solve yourself. The next one, see the radius of a circle is increasing uniformly at the rate of 3 centimeter per second. Find the rate at which area of the circle is increasing when the radius is 10 centimeter. See the radius of the circle, okay, you can take what is this r with the radius, okay, r with the radius, and then the radius of the circle is increasing at the rate of the area. What I can take? A be the area, can I write? A be the area. Next nodiga, the radius of the circle is increasing. What is this data? dr by dt. Is it right now? Radius is increasing, dr by dt 3 centimeter per second. Find the rate at which the area is increasing. What is the calculative? dA by dt, question mark, okay. D, find the rate at which area is increasing when radius is, okay, that means when r is equal to what? 10 centimeter. So, once again we are asking with the area, dr by dt is given. What is the formula for the area? We know that area is equal to pi r square, right. Now, differentiating this with respect to the time t, what I am going to get? dA by dt pi into 2r into dr divided by dt. So, dA by dt is equal to pi into 2 into r. What do you mean by r here? Radius is given, right, that is how much? 10 into dr by dt is given, how much it is? 3. See, it is 20 into 3, that is 60 pi square centimeter per second. So, the area changes at the rate of, okay, 60 pi square centimeter per second, rate of change of area with respect to time, 60 pi square centimeter per second. The edge, an edge of a variable cube is increasing at the rate of 3 centimeter per second, edge of a variable cube. So, now let us take, let x be the length of the edge, okay, x be the length of the edge, x length of the edge, variable cube is increasing at the rate of 3 centimeter, okay. How fast the volume? V, correct, V be the volume, V be the volume, right. See now the data what is given, edge is increasing, rate of change of edge, that is dx by dt, that is 3 centimeter per second. Edge of a variable cube is increasing at the rate of, how fast the volume of the cube increases, that is what? dV by dt, okay, dV by dt, when the edge is, when the edge means it is x, okay, edge is 10 centimeter long, that is x is equal to 10 centimeters. So, now cube, once again we know that volume of the cube formula V is equal to what, you know, x cube. Directly you differentiate the problem with respect to the variable t, okay. Now what I am going to get, dv by dt is equal to 3x square into dx by dt. Okay, 3 into x is given, right, 10 square into dx by dt is 3, that is what your dv by dt. So how much, 3 3s are 9, 9 into 100, it is 900 cubic centimeter per second. So dv by dt is equal to 900, volume changes at the rate of 900 cubic centimeter per second. Next, see, the radius of the circle is increasing at the rate of 0.7 centimeter per second. Let r be the radius, okay, let r be the radius. And what is the rate of increase of circumference? Okay, c, you can take c be the circumference of the circle. See, now radius is changing, dr by dt, how much it is? 0.7 centimeter per second. Radius changes at the rate of 0.7 centimeter per second. What is the rate of increase of the circumference? It is dc by dt is the question mark. Okay. See, now now we know the formula for circumference of the circle. What is the circumference of the circle? C is equal to 2 pi r, right, circumference. Now once again differentiating this with respect to the variable t, what I am going to get, dc by dt, 2 pi into dr by dt. Okay, see, it is 2 pi into dr by dt is given, how much it is? 0.7, see, it is 1.4 pi centimeter per second. So circumference changes at the rate of 1.4 pi centimeter per second. For rectangle, mark this question, 5-mark question in the examination. The length x of a rectangle is decreasing at the rate of 5 centimeter per minute and width y is increasing at the rate of 4 centimeter per minute. When x is equal to 8 centimeter and y is equal to 6 centimeter, find the rate of change of perimeter and area. So now let us start with the, okay, let x, what is x, x be the length of the rectangle, okay, x be the length of the rectangle, and y, okay, y be the width of the rectangle, x be the length of the rectangle, y be the width of the rectangle. See this one, rectangle, okay, see, x is the length, y be the width of the rectangle. So now see what is length of the rectangle decreasing. Remember one thing, increasing rate measurements are always denoted by positive sign and decreasing rate measurements are always denoted by negative sign. The length is decreasing, therefore can I write what, dx divided by dt. How much it is given? Minus, okay. Understand why it is minus? Because of the decreasing rate measurement, 5 centimeter per minute. And width y is increasing, that means dy by dt, it is increasing at the rate of 4 centimeter per minute. Okay. Now when x is 8 centimeter and y is 6 centimeter, rate of change of perimeter. We will go to the first question now. Let P be the perimeter. Okay. Let P be the perimeter of the rectangle. Okay. What is the perimeter? Perimeter means what? Sum of all the sides, right? This is x, this is y, in the rectangle opposite side. 2x plus 2y, is it right? Perimeter is 2x plus 2y, Rp is equal to 2 into x plus y. So now go for differentiating this, right? Differentiating this with respect to t. So what I am going to get, yes, it is rate of change of perimeter. dp by dt is equal to 2 into dx by dt plus dy by dt. See here, that is given by, just observe now, dp by dt is equal to, right, now 2 into, what is dx by dt? What is dx by dt is given? How much it is? Minus 5 plus dy by dt, 4 it is, right. So, how much it is now? Minus 1 into 2 minus 2. So, the perimeter decreases at the rate of minus 2 centimeter per second. Is it right? Centimeter per minute, sorry. Now, the second one here is area, right? What is the question he is asking? At what rate? The area of the rectangle. Area of the rectangle. You know what is the area of the rectangle? It is area is equal to x into y, correct? Length into breadth. So, now carefully differentiate, okay? Differentiating with respect to the variable t. So, what I am going to get dA by dt x into y. Remember how to differentiate by product rule. So, it is x into dy by dt plus y into dx by dt. What do you mean by x? X is given already. How much it is? 8, okay, into dy by dt. What is dy by dt? 4 plus y. Y is given. How much it is? 6 into dx by dt. Dx by dt is given already. Minus 5. So, 32 minus 30, that is once again area, you know, it is 2 square centimeter per minute. So, area changes dA by dt, area changes at the rate of 2 square centimeter per second. Very important question, an examination repetitive question, remember now. So, the length of the rectangle is increasing at the rate of 5 centimeter, width y is increasing at the rate of 4 centimeter. When x is 8 centimeter and y is 6 centimeter, find the rate of change of the perimeter and area. So, we are taken x be the length of the rectangle and y be the width of the rectangle. Length of the rectangle is decreasing because of the decreasing rate measurement. We are using the negative sign, that is what, minus 5 centimeter per second. Width is increasing at the rate of what, dy by dt, it is 4 centimeter per minute. P be the perimeter. First question, perimeter means sum of all the side, 2x plus 2y, 2 into x plus y. We are differentiating carefully. Here the problem occurs now. You are differentiating with respect to t. Here it is x with respect to t, dx by dt, y with respect to t, that is dy by dt. So, we are substituting and we get minus 2. That means what? The negative sign shows that the perimeter decreases at the rate of minus 2 centimeter per minute. Next question comes to area. How area? Area is nothing but length into breadth, x into y. We are differentiating with respect to t, dA by dt. Here x into y means we are using the product formula, x into dy by dt plus y into dx by dt. 8 into 4 plus 6, because x and y values are given already in the problem. So, 32 minus 30, it is 2 square centimeter per minute. So, area changes at the rate of 2 square centimeter per minute. Okay. Now, we come to the next one. A balloon which is always spherical, on inflation, it is inflated by pumping 900 cubic centimeters of gas per second. Spherical shape, a balloon which is in the form of what, you know, sphere. Find the rate at which the radius of the balloon increases, right? See, we can take, let V be the volume, okay, V be the volume and R be the radius, right? V be the volume, R be the radius. Is it right? This is the data what he has given. So, now how much it is given? Volume is given, right? That is what dV by dt. It is, see here, on inflation it is inflated by pumping 900 cubic centimeter. That means, see how can you identify cubic centimeter? Volume, that is always volume, you know. Areas means surface area or area, it is always in square centimeter. So, volume, that is dV by dt, it is 900 cubic centimeters, right, cc of gas per second. Find the rate at which the radius increases. We want to calculate dr by dt, rate of change of area, sorry, radius, dr by dt. When, okay, when the radius is, when r is equal to, how much it is? 15 centimeter, when r is equal to 15 centimeter. So, now volume is given, radius is given, we want to find out the rate of the change of what, you know, area, sorry, radius. what is the formula for the volume of the sphere? 4 by 3 pi r cube, 4 by 3 pi r cube. Now, if we differentiate this, okay, with respect to t, what I am going to get now? dV by dt is equal to 4 by 3 pi into 3r square into dr by dt. Okay. See, now 3 gets cancelled. 4 into pi into r is 15 square, okay, into dr by dt is the question mark, but dV by dt is given as 900, right? So that is dr by dt. See, it is 900 is equal to 225, 4 side is 900, okay, into dr by dt. So 900 gets cancelled. So therefore dr by dt is equal to 1 by pi centimeter per second. So the radius changes at the rate of 1 by pi centimeter per second. See, this is the 5-mark question. A ladder 5 meter long is leaning against a wall. The bottom of the ladder is pulled along the ground away from the wall at the rate of 2 centimeter per second. How fast the height on the wall decreases when the foot of the ladder is 4 meter from the wall. See here, I think you have seen this, the ladder which is always rested against a wall and on the floor. So now origin, see here, this is the ladder which is rested like this, right? See, the length of the ladder is given, AB is the length of the ladder, okay. See, the length of the ladder is how much? It is 5 meter. Now you can take this, the distance of the ladder, see, A is the lower end, B is the upper end. See, this is x meter and this is some y meter, okay. So that is, x meter is the distance of the ladder at the lower end from wall, and OBC, distance of the ladder at the upper end from the floor, y meter. So that is, let AB is equal to 5 meter, okay, OA is equal to x meter and OB is equal to y meter. So now what is this? See, the bottom of the ladder is pulled along the ground, okay, bottom of the ladder is pulled along the ground away from the wall. This is the bottom, it is pulled along the ground, that is dx by dt. How much it is given, you know, it is 2 centimeter per second. So converted to meter, 0.02 meter per second. The question is, how fast height on the wall decreases, this one, right? So that is dy by dt, rate of change of the height dy by dt when foot of the ladder is, okay. So what is the foot of the ladder? This one now, foot of the ladder means x is equal to 4 meters. See, we can easily go with the figure now, okay, because it is a right angle triangle. So therefore can I apply x square plus y square is equal to what, you know, 5 square, right? Call this as equation 1. See now, when y is equal to, sorry, when x is given, right, when x is equal to 4 meter, yes, what happened? 4 square plus y square is equal to 5 square, y square is equal to 25 minus 16, that is 9, therefore y is equal to 3 meter. See, once you determine y, now go for differentiating the equation 1 with respect to the variable t, that is 2x into x square differentiation with respect to t, 2x into dx by dt plus 2y into dy by dt, which is equal to 0, or you can write x into dx by dt plus y into dy by dt, which is equal to 0. Can you replace now? Can you replace it as, okay, or you can write y into d, because we want dy by dt, right? So that is equal to minus x into dx by dt. So what is y here? Y is 3, it is already obtained, into dy by dt, it is an unknown, minus x. What is x here? 4 into dx by dt. What is dx by dt? 0.02. So finally dy by dt is equal to 4 into minus, that is minus 0.08 divided by 3, correct? It is meter per second, or you can write dy by dt, I think into 100 it is 8 by 3 centimeter per second. So, very important question you see, 8 by 3 centimeter per second dy by dt. That is why the negative sign, why the negative sign shows, you know, because the negative sign is because of the meaning that the top of the ladder, the upper part of the ladder is decreasing because of that negative sign. Once again, this is also 5-mark question in the examination. A particle moves along the curve 6y is equal to x cube plus 2. Okay. What is the given curve? 6y is equal to x cube plus 2. Find the points on the curve at which y coordinate is changing, that is the rate of change of y coordinate, right, that is dy. Y coordinate is changing 8 times as fast as x coordinate. So, that means can I write dy by dx is equal to what? 8. Now, go for differentiating this, call this as equation 1, differentiating with respect to t. Okay. 6 into dy by dt is equal to 3x square. So, dy by respect to x also you can take, with respect to x only it is. See now, 6 into dy by dx is given, right, 8, which is equal to 3 into x square, 3 1s are 3 2s are, x square is equal to 16, x is equal to what? Plus or minus 4. What we require? Points on the curve. So, now you have to take in 2 different cases. When x is equal to 4, what happens? Take the equation 6y is equal to x cube plus 2, 6y is equal to 4 cube plus 2, is it? 64 plus 2, 66, that means y is equal to 11. So, therefore, one of the point is given by 4 comma 11. Similarly, when x is equal to minus 4, once again you can take x cube plus 2, 6y minus 4 cube plus 2. So, how much it is? Minus 64 plus 2, minus 62. So, y is equal to minus 62 by 6, minus it is 31 by 3. So, here the point is minus 4 comma minus 31 by 3. See, therefore, the required points, okay, the required points are, one is 4 comma 11, another one is minus 4 comma minus 31 by 3. Okay. Today we will stop this, tomorrow I will continue the problems further.